Okay, so in this video we're going to cover section 1.5, and this is going to sort of be applications of quadratic equations. So this is going to be a word problem section with quadratic equations involved somehow. So for our first example, we're going to say a piece of machinery produces rectangular sheets of metal that have length 3 times the width. So we'll say a machine makes rectangular sheets of metal with length 3 times the width. Okay. So next they say 5-inch squares are cut out of the corners, so the resulting shape can be folded into a box with no top. So 5-inch squares are cut from corners. The result can be folded into a box with no top. It tells us the volume of the box is supposed to be 1,435 cubic inches, and we want to find the dimensions of the original sheet of metal. So the box volume is 1,435 cubic inches. We want to find dimensions of original sheet of metal. Okay, so let's go through and try to set this up. So first of all, we're going to draw a picture. So we'll say, all right, we got this rectangle. And the rectangle has width W. So there's width W. And since the length is 3 times the width, the length is 3W. So next, little 5-inch squares are going to be cut from this box. Or sorry, cut from this sheet. So these are little like 5 by 5-inch squares. And if we fold the remaining flaps up along these dotted lines, then we can get a box with no top. So we fold that and we get some sort of box kind of like this that has no top. Okay, so what we need to do to solve this, we need to go through and we need to figure out what is the length of this part here, because that part there will become the length of the, that'll be the length of this box here after you fold it up. And we need to find what is the width of this little part here, and that will correspond to the width out there. We know since these are little 5 by 5 pieces, and when you fold them up, this height will be 5 inches, 5 inches tall. So that box height there, let me write that slightly better. That's probably a bad way to do it. Height there will be 5. All right, so if the length of the overall box is 3W, and we come in 5 inches here, and we come in 5 inches there, then what we really have is 3W minus 10 for the length of this interior part, which will become the length of the new box. If the width here is W, and we move in 5 inches there, and we remove 5 inches there, we'll get W minus 10 for the width of that box. So since length times width times height equal volume, the length times the width times the height will equal what the total volume is supposed to be. So I'm going to take that 5 that's there. I'm going to divide both sides by 5 to try to make the numbers easier to manage. So the 5 can cancel here. We get 3w minus 10 times w minus 10. That's going to equal, let's see what 1435 divided by 5 is. That is 287. So then what we'll do is we'll FOIL out this term. So 3w times the w is 3w squared. Outer will have minus 30 w's. Inner will have minus 10 w's. Last, negative 10 times the negative 10 is a positive 100. That equals 287. So we'll subtract the 287 across. So we'll get 3w squared. 30 minus 10 is negative 30 minus 10 is negative 40w. And then 100 take away 287 is negative 187. So that equals 0. And I'm not seeing how this factors, so we're going to say A is 3, B is negative 40, and C is negative 187. And we'll put that all in the quadratic formula to solve for the width. So we have negative B plus or minus square root of B squared minus 4 times A times C, all that over 2 times A. So our width will be minus a negative 40 is positive 40, plus or minus square root of something. Let's see what's going to be under that square root. Negative 40 squared will be 1600 plus, because minus a negative is positive, 12 times 187 is 2244. So if we get that plus 1600, we get 3844. And that's all over 6. So we say width is equal to, let's figure out what the square root of 3844 is. Happens to be 62. So we get 40 plus or minus 62 over 6. So that's going to turn into 2 solutions. We get 40 plus 62 divided by 6, which is 17. So was this inches or this was all inches? So that'd be 17 inches. Or 40 minus 62, all that divided by 6, is negative 3.667 inches. Well, if we're talking about the width of a box, it doesn't make sense to have something with negative width. So we're going to throw the negative one away and say, okay, the width is 17 inches. We're supposed to find the dimensions of the original sheet. We know the width of the original sheet of metal. So the length would be 3 times the width. So the length is 3 times 17, which, length, that should be, I think it's 51. Yeah, so that's 51 inches there. And we got our problem basically wrapped up here. Just drew the picture, generated the equation, did length times width times height equal the volume they gave us, generated an equation. We were able to solve it down to here, used the quadratic formula to figure out which widths they were, threw away the one that didn't make sense because it was negative, kept the positive, then found the length and width, 17 inches and 51 inches of the overall shape. So next one that we're going to look at. This is example 2 from section 1.5. So if y'all look in your, look in the e-copy of the textbook that came with your access code, you can find these problems there. So we say a piece of property is the shape of a right triangle. We get the longer leg is 20 meters longer than twice the shorter leg. So the longer leg is 20 meters more than twice the length of the shorter leg. And the hypotenuse is 10 meters longer than the longer leg. And we want to find the dimensions of the lot. Or I guess we could say the property. Okay, so first of all, let's draw a triangle. So we got a right triangle here of our property. We'll call S the shorter leg, L we'll call the longer leg, and H we'll call the hypotenuse. So the longer leg is 20 meters more than twice the length of the shorter leg. So the longer leg is twice the shorter leg plus an extra 20 meters. The hypotenuse is 10 meters longer than that, so the hypotenuse is twice the shorter leg. It would be plus 30 because it's 10 meters longer than the longer leg. The equation we're going to use is Pythagorean's theorem. So we're going to use this equation here. So what we'll get is S squared plus the longer leg squared equals the hypotenuse squared. The hypotenuse is always C. So we have this. We're going to have to set up and FOIL this out, and then we'll combine like terms, and we'll see if we can solve the result for S. Okay, so we'll FOIL out the first bit, so we get S squared plus 2S times 2S is 4S squared. Outer is 2S times 20 would be plus 40S. Inner is 20 times 2S would be plus another 40S. Last would be 20 times 20, which is plus 400. That equals 2S times 2S is 4S squared. Outer is plus 60S. Inner is plus a 60S. And last is plus 30 times 30 is 900. So I'm going to scoot all the terms over to the left-hand side. So I'm going to subtract the 4s squared here. It'll cancel. Actually, we get it canceling over here as well. So that's kind of weird. We got minus 60s. We get minus 60s. So those cancel, cancel. Got minus 900. So if we look at what we're left with, we got S squared, plus 40 minus 60 is negative 20, plus 40 minus 60 is another negative 20, so two negative 20s make a negative 40s. 400 take away 900 is negative 500, that all equals 0. I need two numbers that multiply to negative 500 and add up to negative 40, and negative 50 and 10 will work for that. If you didn't see out factored, you could use a quadratic formula. You would just set A equal to 1, B would be negative 40, and C would be negative 500. So we're down to here. So I'm going to set each of these terms equal to 0. So either S minus 50 equals 0, which says S is 50, or S plus 10 equals 0, which scoot the 10 on over, says S is negative 10. These are supposed to be the lengths in terms of meters of a property. It doesn't make sense to say my property has negative 10 meters for a length. So that one's out. The shorter leg is 50 meters. The longer leg was twice the shorter plus 20. So twice 50 is 100 plus 20 says 120 meters is the length of the longer leg. Then the hypotenuse was 10 meters longer than the longer leg. So 130 meters would be the hypotenuse. And at this point, we've got all bits of information we needed taken care of and totaled up, and we found the lot dimensions. So we get an equation next. This is going to be the, if air resistance is neglected, so if there is no air resistance, then the following equation, S equals negative 16t squared plus V naught times T plus S naught. This will tell the height of a projectile in feet if it's shot upwards. So this will be height of projectile shot up. This will be in feet. T in this equation is time. So that'll be time. This will be time. And then time is going to be in seconds in both of these. V naught will be initial velocity. Which will be in meters per second, feet per second. Distance units are feet, so this will be feet per second. And S naught will be initial height. And that will just be in feet. So we have this equation here. We're going to use this equation to solve our next example. So the next example says, example 3, says a projectile is launched up from the ground with initial velocity of 100 feet per second. So we're neglecting air resistance, and we want to find, so we'll say there is no air resistance. And then part A, we want to find after how many seconds will it be 50 feet above the ground? And part B will be when does it return to the ground? Okay. So they told us that we launched from the ground, which means the S naught symbol is 0, because if you're on the ground, you're at a height of 0 feet. They said that our initial velocity, V naught, was 100. So we can get our equation. It'll be S equals negative 16t squared. So S's height equals negative 16t squared. Plus V naught T will be plus 100t plus 0. So that'll be plus 100t. And plus 0 doesn't do anything, so if we wrote plus 0, that doesn't add any extra information because adding 0 does nothing. So we're going to leave our formula like this. So this is a formula. I can input time, and I can get height, or I can input a height, and I can solve it for the time. So for part A's solution, we're going to set the height equal to 50, and we're going to solve the equation for t and see what times correspond to a height of 50. So I'm going to move the negative 16 across, and I'm going to move the 100 across. So we'll get 16t squared minus 100t plus 50 equals 0. We can divide all this by 2. So 16 divided by 2 is 8, so we get 8t squared. Minus 100 divided by 2 is 50, so we get minus 50t. Plus 50 divided by 2 is 25. That's going to equal 0. And then, see, I don't see how that factors, so I'm just going to say A is 8, B is negative 50, and C is 25. I'm going to put this into the quadratic equation to solve. So we'll get time equals negative b plus or minus the square root of b squared minus 4 times a is 8 times c is 25, all that over 2 times a. So what we get here is minus a negative 50 is positive 50. We get plus or minus, let's see, negative 50 squared would be 2500. 4 times 25 is 100, times 8 would be 800. So that'll be square root of that, all that over 16. So my time equals that. I'm going to type each of those individually. 50 plus square root of 1700 over 16, and 50 minus square root of 1700. I'm going to put both those in my calculator. And see what we get. Okay, so the first one I'm getting is 5.7 seconds. And the second one I'm getting is 0.55 seconds. So these both make sense because what's happening here is your projectile heads upwards from the ground, and so it'll pass 50 on the way up at 0.55 seconds, and then when it's falling back down it'll pass 50 again at 5.7 seconds. So that is our answer to part A. Part B says, when is this thing going to fall back to the ground? So we'll set the height equal to 0. So for part B, we'll say, all right, 0 is the height. That equals negative 16t squared plus 100t. And then we're going to solve this. We'll factor out a 4 and a t. So we'll get two things that multiply together to equal 0. Either 4t equals 0, which says t equals 0. This isn't really the one we want. This is one that was on the ground before we launched it. Or negative 4t plus 25 equals 0. So move the 4t across. So 25 is 4t. Divide by 4. So 25 fourths is t. This is the one that we want. This is when it falls back to the ground. When we do that, we get 6.25 seconds is t. So that is when we return to the ground. Okay, so we're going to have one last problem we're going to do here. This is going to be problem 25 from the textbook. If you look in the exercises from 1.5, that's where you can find this one. So we basically have, you want to buy a rug. For a room that is 12 feet by 15 feet. You want to leave a uniform strip of space around the rug. And the rug will be 108 square feet. For area, I guess we could say. Kind of worded that weird. We want to find the dimensions of the rug. So find dimensions of the rug. So first let's draw a picture. We got this room. This room has a rug in it. We're leaving a uniform strip of space between the rug and the wall. The room is 12 by 15. We don't know this strip of space, so I'm going to call that X, my unknown. So the space between the wall and the rug is X on all sides. So when I do that, the width of the rug is 12 minus 2x, and the length of the rug is 15 minus 2x. Because if you take the total 12, you come in x from the bottom and x from the top, so you move x twice. If you have the whole 15, you move in x from the side and x from the other side. So the area of the rug that's supposed to be 108 will be the length of the rug times the width of the rug. And then that's something we can solve. So let's see here. What is 15 times 12 is 180. Outer would be 15 times negative 2x would be minus 30x. Inner would be minus 24x, and last would be plus 4x squared equals 108. Going to subtract the 108 across and rewrite this with the x squared term first. So we get 4x squared minus 30x minus 24x is minus 54x. That'll be plus 72. Equals 0. I'm going to divide everyone in half. So 2x squared minus 27x plus 36 is 0. Let's see. This factors as a 2x. Let's see. If 2x meets up with the 12, that makes a 24. And then the 3x added to the 24x will make a 27x. So we get that this factors like that. We're going to set each factor equal to 0. So 3 slides on over, says 2x is 3. Divide the 2, says x is 3 halves. On this side we get x minus 12 equals 0. Slide the 12 over, x equals 12. So 3 halves is 1.5. So this is saying the border here could either be 1.5 or it could be 12. Well, the room's only 12 feet, so you can't come in 12 feet from either side, so 12 is not going to work. So the border is 1.5. So basically, we come in 1.5 here, we come in 1.5 there. That's a total of 3 feet that we remove. So 12 minus 3, we could say 12 minus 1.5 minus 1.5 is 9. And for the 15, we come in 1.5 here and 1.5 there. That is 15 minus 3 is 12. So the rug is 12 feet by 9 feet. And that will be the dimensions of the rug. So that basically wraps up section 1.5. So we're going to stop there.